chapter 4, that is your atomic structure and chemical bonding. It is what? Atomic structure and chemical bonding. Okay? Now this chapter starts in your book in page 53. It starts in your book in page 53. Okay? However, we are not going to start from page 53. We will start from page 59. We'll start from which page? Page 59. Why? Why will we not start from the beginning? Because in the beginning there is a lot of history. Okay? And the history about the discovery of the atom, different atomic models. How did we come to the model that we are going to discuss today, Bohr's atomic model? Those, and also the discovery of different subatomic particles. Okay, those things are important. I'm not saying they are not important, but we have already discussed some of these, most of these actually, in class 8, in class 8, and we also have them in class 9. However, we will not discuss this too that much right now. We will only discuss these historical parts later on in a future video. In this video today, we are going to discuss mainly from page 59. That is, we are going to discuss the atomic structure part. We are going to discuss what? The atomic structure part. Now this part also has been done in class 8. This is a bit of a recap from what you already know in class 8. Okay? So we are going to discuss straight away into the Bohr's atomic model, which is the model that you will study here in class 9 as well as what you have studied in class 8. So, if you remember, according to that model of atom, we have the center of the nucleus, center of the atom. We have the center of the atom, which is known as the nucleus. We have the center of the atom, which is known as the nucleus. And we have imaginary circular pathways which are surrounding the nucleus, and we call them what? Shells. This is the nucleus and surroundings parts are known as shells or orbits. Shells or orbits. Okay? Shells or orbits. Now, the nucleus is the center of the atom, right? It is the center of the atom. And in the nucleus, we have some subatomic particles, right? Do you remember subatomic particles? Subatomic particles, who are they? Protons and what? Neutrons and electrons, right? Subatomic particles are the particles which make up the atom itself. Atom itself is made up of smaller particles. These particles you already know. They are protons, electrons and neutrons. Protons, electrons and neutrons. Now, in the nucleus you have got proton and neutron. Proton and neutron. And outside in the imaginary parts known as the orbits, the electrons are revolving around the nucleus. Electrons are doing what? They are revolving around the nucleus. Okay? If you remember that, we have already discussed these things in class 8. Now, we need to know certain properties, certain things about the subatomic particles. Let's discuss those. So we got the protons, the neutrons and the electrons, our three subatomic particles. These are what? These are subatomic particles. Now, these subatomic particles, proton, neutron, and electron, they have mass, they have charge. Let's talk about them. Mass. Now, these are very, very small particles. If you take their mass in gram or in kg, it will be a very, very small value. If we take the values in gram, it will come around 1.6 into 10 to the power minus 24 gram. Okay? If you take the values in gram, it is coming like that. If I take neutron, it is also quite the same, 1.6 into 10 to the power minus 24 gram. Electron, however, is much smaller than them. 9.1 into 10 to the power minus 28 gram. Okay? 9.8 into 10 to the power minus 28 gram, which is very small compared to the first. As you can see, it is 10 to the power minus 8, but these are only 10 to the power minus 24. So it is much smaller value. Okay? But since they are very small, we can take their value in atomic mass unit. Now, atomic mass unit is what we have discussed in chapter 1. We have discussed atomic mass unit in chapter 1. Is it not? The language of chemistry. So, I am not discussing that again here, but you can refer to chapter 1 if you have forgotten what atomic mass unit means. So, if we take in atomic mass units, it will be 1. We assume it to be 1. As it is in atomic mass units, it is 1. We are comparing to remember the mass of 1/12 of the mass of carbon 12 atom. So, in comparison to that, it is 1, this is 1, and this is 1 by 1840. So, it is a very, very small value. It is a very, very small value. We can almost take it to be 0. Okay, it is so small that it can be ignored, negligible. It is not 0, but it is very close to 0. It is negligible as compared to the proton and the neutron. Now, when we talk about charge, in coulombs, their values in coulomb, that is a unit of charge, SI unit of charge. In coulombs, if I take the value of this is, proton is plus 1.6 into 10 to the power minus 19 coulomb, and that of neutron is 0, and that of electron is minus 1.6 into 10 to the power minus 19 coulomb. Okay? As you can see again here, the charge of proton and electron are the same, identical. However, the neutrons has no charge. Now, these are all discovered through various experiments which we are not going into. These values you have to know. So, this is the value of charge in coulombs for proton, and this is for electron, and they are having the opposite sign, but they are having the exact amount of charge. The value is same, sign is opposite, and neutron has no charge. And finally, if we move on to the charge in electronic units, which we will use more often here, charge in electronic units, electronic units, this will be considered as plus 1, this is still 0, this is minus 1. So these are some of the properties of the subatomic particles that you need to know. The mass and the charge. First in gram I have given here, and the units in AMU. Of course, in AMU units, the values are given here, and the charge in coulombs, and then in the electronic units. So you need to know these things. But what do we learn from this chart? What do we learn from this chart? We learned several things from this chart. We learned first of all that proton and neutron have far greater mass than electron. Is it not? Electron has mass, however it is much less compared to proton and neutron. Is it not? As you can see, 1 by 1840. So we consider it to be negligible. So depending on that, we know where proton and neutron are found. Is it not? Where are proton and neutron found? Just a while ago we discussed this. Proton and neutrons are found in the nucleus. Is it not? They are found in the nucleus. And we call them nucleons. Together we can call them nucleons. So protons and neutrons, they are found in the nucleus. And since they are having far greater mass than an electron, we can say that the nucleus of the atom has almost the entire mass of the atom. Almost the entire mass of the atom is contained within the nucleus of the atom. Okay? Next thing that we notice from this chart is the charge. Proton is having positive 1 charge, electron is having negative 1 charge. Electron is having negative 1 charge. Proton is having positive 1 charge, right? So, and the neutron is having 0 charge. That's clear? So, we can say that the nucleus as a whole is positively charged. The nucleus as a whole is positively charged. The entirety of the nucleus is positively charged. Why? Because who is present? Who is present in the nucleus? Proton and neutron. Is it not? Proton and neutron. Now proton has positive charge, neutron has 0 charge. Is it not? So proton and neutron together are there as nucleons in the nucleus. But since only proton has charge, it is having what charge? Positive charge. So the entire nucleus is positively charged. And outside in the shells, in the orbits, the imaginary paths in which the electrons are moving, the electrons are having what charge? Negative charge. So negative charge electrons are moving in the shells, the imaginary paths in which they are moving around the nucleus. Fine? So this is what we know about the subatomic particles. Now, one more thing, and the very important thing that we are coming to is atomic number. Is what? Atomic number. We are going to talk about two very important things now. Atomic number mass number. Now one thing that was found in an atom, the number of protons and electrons are always found to be same. In an atom, the number of protons and electrons are always found to be same. And we know that the proton is what? Plus 1 charge. And the electron is what? Minus 1 charge. So the number of positive charge is always equal to the number of negative charge. So atom as a whole is neutral. Atom as a whole is neutral. Neutral means what? No charge. Okay? Atom as a whole is neutral. The neutrons are neutral, they don't have any charge. Atom has charged particles. It has protons, it has electrons, but this is positive, this is negative. Since the number of positive and number of negative is same, negative charge and positive charge, number of particles are same. So overall the charge becomes 0 and the atom as a whole is neutral. Okay? Now coming to the topic mentioned on the top, atomic number. Atomic number is actually nothing but the number of protons in the nucleus. So atomic number is equal to the number of protons in the nucleus. But just now we discussed that proton and electron are always the same in number. Is it not? So if atomic number is equal to the number of protons, atomic number is equal to the number of protons, it is also equal to the number of electrons. It is also equal to the number of electrons. Okay? Now, mass number is the number of protons plus number of neutrons. Okay? Number of protons plus number of neutrons. So this we have to remember very carefully. Atomic number is what? Number of protons, and since we know that proton is always equal to electrons, number of proton is always equal to electrons in an atom. Okay? Then we can say that number of proton is also equal to number of electron. It is equal to the number of, it is equal to the atomic number, which is given the symbol Z. And mass number is given the symbol A, and we can say that it is equal to the number of proton plus number of neutron. Okay? This is a very important information that you need to know. Now, having known this, if we do not know the number of neutrons present in an atom, we can also find out the number of neutrons by subtracting the mass number and the atomic number. We'll take the mass number, and if we subtract the atomic number from it, we get the number of neutrons. Okay? So that's what we get. If you want to find out number of neutrons, we take the mass number and minus from it the atomic number. We can write it like this also. Mass number minus number of protons, because, well, number of protons is also equal to the atomic number. Is it not?